Hello everyone. Today let's focus on a key concept in data models, really focusing on the types of data models. Two big important ones that we're going to talk about today are going to be relational and document models for the data models used in system design. So today we are discussing two predominant data models in the real world of databases, relational and document. So imagine a world where everything is categorized and placed in a box with a specific label. That's the essence of the relational model. And it was introduced by Edgar Codd in 1970. Where the model structure is about data and how do we organize it in tables. And a popular application for a relational database is Microsoft Access. There's also SQL as well. Just to name two. And this model structures data into tables, which is like a label box, each containing rows. Notice how each of them are in boxes and they're all containing rows, and they're all containing key components of data, even including tuples as well. It's overall a systematic approach that enforces a strict schema and is excellent for data with a regular structure. So. Despite skepticism about its efficiency and its inception, by the mid-1980s, relational database management systems with SQL as a query language became the standard. This model was ideal for business data processing, such as transactions and batch processing on mainframe computers between the 60s and 70s. So it's great for transactions. I'm actually going to highlight this part as well, use a different color. Let's see if I can highlight this. And fast forwarding 20 to 30 years later, and relational database management systems still command the field. And they power diverse applications from e-commerce to online publishing. However, no technology reigns unchallenged forever. The rise of NoSQL in 2010s marked a shift towards more flexible data storage. So, the NoSQL buzz originated from Twitter's hashtag capturing the growing frustration with the rigid structure of relational schemas and the desire for a model that could handle more dynamic data and larger scales more efficiently. This is where the concept of document models came to play. They focus on dynamic data. It was introduced in 2010s, in the 2010s, they handle unstructured data. And it was originating from Twitter's hashtags in order to be able to help capture the growing frustration with the rigid structure of relational schemas and the desire for a model that could handle more dynamic data and larger scales more efficiently. Here, the document model, just to give an example, relaxes the strict schema of relational databases, and the data is stored specifically in self-contained documents such as JSON or XML. So JSON for documents and XML for relational. Databases are here, and then document. Coinciding over here. And that's also including NoSQL. NoSQL meaning no structured, rigid databases, and focuses on unstructured. So relational focuses on structured, unstructured. And so therefore, this is just the brief concept overview between relational and document models. Let me just clean some of this up for you folks. Dynamic data, relational model. There we go. So let me just move this over a little bit. There we go. So this is just dealing with relational models and document models. Now, to be able to cement the idea of the concept between relational and document databases and models, let's go over a vivid example between two real-world examples focusing on LinkedIn as a relational database, a relational model, and then a law school application that is using JSON data to be able to use a document model to structure out different forms of data. So on LinkedIn, just to give an instance of this, I will just put in right here. Let me just take care of that. There we go. Relational model, LinkedIn / resume, because you're going to have a person, and then you're also going to have their title, experience, and also career and education too, as just a number of fields. For this can all be formulated within a structure, and therefore that data model can also be applied to other avenues at the same time, depending on how you want to encapsulate each object that you are already programming. And this is also branching off of object-oriented programming as well, just for further context. And meanwhile, for the law school app for a document model, for what we are seeing over here, this is a JSON document, really, just with a number of fields and different means of data in of itself. What it's doing is that this is actually a law school test app that I'm doing as a side project right now. And each field it's going to have a series of questions, question choices, and it's probably going to have some type of passage that we have for each question, because this is unstructured data that we are dealing with, since it is we are also dealing with different types of tests as well. Type of tests, because the LSAT has 4 sections as well. And plus, choices are saved as well. Choices are saved locally as a cache on the user's phone. That way they can take the test without the need for Wi-Fi. And so that would just be an example, really, for JSON data. I'm going to see if I can zoom in here. It's just a lot of text that we're dealing with. So there we go. That's better. So this JSON document that we have is going to have a test number, the test type, the time required, directions, questions as well. And each series of questions is an array inside of an array where we are going to have a given prompt, and we're going to have choices as well with the correct answer and explanation. Then we're also going to refer that for each of the following passages that we have accordingly, and then treat this organized form of data into an unstructured document, so that way the choices can be saved dynamically, since users probably want to take a test, maybe restart a test at the same time, and all that data can actually be restructured and manipulated in real time. So these are just 2 examples that we have for a resume, and then also a law school application that we are making. Let me just move this over. There we go. So now let's go over a vivid practice example, or practice problem, to be able to understand the scope of a relational database and how to carry it about. So let's consider this type of data and its structure. If the data is highly structured and interconnected with clear one-to-many relationships, like employee to their job positions, then we will apply a relational model in this case, since we are dealing with employees, positions, I could say education, or seniority. We would apply a relational model. To structure our data. And the question is if we can automate our structure unanimously across the board, it's going to be relational model. In order to actually assess what data model we would use, a relational model versus document model, there's really 3 components that we need to consider in order to do so. So they would be: 1, assess the data structure. 2, evaluate the query pattern. 3, And finally, consider the application's flexible needs. Flexible needs when we apply it into the real world. When we are assessing the data structure, what we need to consider the type of data and structure. If the data is highly structured and interconnected with clear one-to-many relationships, like employee to their job position, the relational model will seem appropriate. And in this model, each employee has a unique identifier and tables for job position. So if we have, for instance, if we have a unique identifier and table we can bring, we'll do a relational. Just think of it as if we can make a table out of this. If not, then we're going to have to go with the document model. And the table can be used for job positions and education. Be used for example, job positions and education. Now, to evaluate the query pattern, we need to reflect on how often and in what way the data will be accessed. If you need to perform complex transactions or queries that involve multiple tables and relationships, so if we need to do multiple queries for multiple tables, we'll do a relational model. Relational model. And we need to figure out for relational models have data consistency, and it's all structured from the beginning. And finally, when we consider the application's flexible needs, we need to ask ourselves if the application requires schema flexibility. If you need the ability to quickly adapt to changing data structures, such as new fields without database migration, the document model would be actually beneficial. But since we are dealing with structured data, and not much change, is occurring, we do a relational. And another thing that we also need to point, I apologize for not including this yet, but this is the last one. We also need to consider the scalability and performance. consider scalability and performance. And we need to consider volume of data, faults, and potential failures. The data model in of itself, when it comes to relational databases, would typically rely on something that is already structured and already established and already knows exactly the protocols between how to handle such errors and how to scale with larger volumes. So with knowing exactly between the differences between relational and document models will be our next practice problem. But in the context of relational models, in terms of scale, relational models don't seem to be they don't perform better compared to document models, because document models deal with unstructured data and can abide by the flexibility and such. But of course, you can interchange between relational and document models, but you have to understand the context of the problem they're actually dealing with to begin. So moving out from this. So yes, in order to implement our structure, we also need to understand, can we make a table out of this? Is it going to be consistent data? Will nothing really change that much? We need to assess the data structure, evaluate the query pattern, and consider application's flexible needs. If there's greater flexibility needed, we'll use the document model. If it's already structured, we'll use a relational model. And then we will have to consider the scalability and performance as well. So let me just move out even further. Actually, I'll just move this. 1 second. There we go. So this is practice example 1. Now let's focus on the document model side over the relational model. So we're going to deal with our example within a content management system. Now a content management system is a data system that is really, as the name suggests, focuses on content. So we're going to have different data dealing with different data, where it could also obtain and abide by articles, video, images, and other media. And with the document model, the data is unstructured. With the data in itself unstructured, that means it's going to be dynamically increasing, so we can add on new forms of data throughout the entire content management system. So it's always being dynamically added and ever expanding. A good example is NoSQL. And I'm just putting up the Wall Street Journal as like one example as content management system, because you're dealing with articles, for instance, images and video, and forms of unstructured data that need to be ever expanding as well, because every day there's going to be some news. So for a content management system, we're dealing with a dynamic website, as the name suggests, at the same time with multimedia elements. And the elements for us to consider applying a data model are going to be the following. 1, we always need to assess the data structure. 2, evaluate the query pattern, consider applications, flexibility needs, and assess scalability and performance. Now, these parts are going to be focusing on the document model as a whole. So the way how we assess the data structure to decide on a document model is that our data is less structured, no table can be applied, it's ever expanding, it's ever expanding with different forms of data / content on a consistent / daily basis. The document model could be a better fit here, which allows for each article to be encapsulated by its authors, media, and other categories to fit inside of a single document, since, for instance, an author may include a video or a couple images to be able to explain the point. And so in order for us to evaluate the query pattern, we need to consider a content management system fetching complete articles along with the associated data display. So fetching articles and its associated media, display, and cache layer. Like, for instance, video. Like, that's a good one. The document model's benefits, it's also beneficial locally. Like a YouTube video, for instance. For example, like you can have it play locally even if you're not connected whatsoever. And the document model's locality benefits means that fetching the data with a single query, and it simplifies the data retrieval and reduce server load. Okay, so we reduce the server load and simple query. Extraction. We'll have to consider the application's flexible needs, dynamic, flexible needs, the data is ever expanding, because the content management system needs to adapt to varying content types and structures. The documents model schema's less approach allows one to introduce new content types and modify existing ones, and it overall impacts the database's schema, offers flexibility and speed. And finally, we need to assess scalability and performance. In a content management system, especially those with high traffic that require efficient data retrieval, high traffic requires efficient data retrieval in real time. And the document stores offer faster reads by storing related data together and can handle high throughput associated with web content delivery, making them ideal for the scenario. So, easy retrieval. And faster reads. And handles high throughput of content delivery. Much like in the case of uploading a YouTube video. Because every time you upload a YouTube video, it's for every single data system, we need a database, cache and queue. While the YouTube video is actually being uploaded in of itself, there are moments where there's elements of locality as well to be able to have the video already be uploading at certain key points. And also, if one is searching a video in real time, they're able to have the video also come down and load simultaneously at small chunks and tidbits, also depending on the definition and quality of the video as well. So in of itself, YouTube uses a document model type of data system because of the amount of content that's also required. And that's also replied, for example, the Wall Street Journal with articles, videos, and such. So let me just move all these entity steps to the side. There we go. All right, there we go. So yes, so in our document model, what we're doing is that we're dealing with different modes of data. The document model is great for unstructured data. For the data in itself is dynamically added, and all of our 4 points that we already have is that we need to assess the data structure first, evaluate the query pattern, consider application's flexibility needs, and assess scalability and performance. For in the first part, while assessing the data structure, our data is already considered less structured since one, we're dealing with different forms of data such as articles, videos, and images and content, and no table can be applied. The system that we are applying it to is ever expanding and requires fast retrieval as well. We need to evaluate the query pattern, like how well will be efficient if we have different forms of media. For instance, that could be very high amounts of gigabytes or storage. We need to fetch articles and its associated media display and cache layers, like for instance the video, and it's beneficial locally because one could have parts of media already stored locally to the user in simplifies query processes, and it's a simple query extraction to be able to get that specific form of media. And we have to consider applications flexibility needs. If the content is ever expanding, has higher traffic, then document model will be well assessed. And assessing scalability and performance, we already have, for instance, high traffic requirements, and we have efficient data retrieval in real time, so the caches is completely updating. And we have easy retrieval and faster needs in handling high throughput of content delivery, like uploading a video on YouTube or searching for it as well, between the database, caches, and queues. And so, yes, this was a video, lecture series video of data models focusing on document models and relational models as well, and vice versa, relational models and document models. Thank you again for taking time to watch this. If you found this helpful, be sure to like and subscribe, and feel free to. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.